Here's problem 827. A 2 kilogram block is projected down a plane that makes an angle of 20 degrees with the horizontal and an initial kinetic energy of 2 joules. If the coefficient of kinetic friction between the block and the plane is 0.4, how far will the block slide down the plane before coming to rest? So let's take a look at this situation. Here's our plane at a 20-degree angle. Here's our block, and the mass of the block is 2 kilograms. And let's say it actually goes down some distance d down this plane. So that's going to be our distance d. We're going to proceed then from point A to point B to our final location. Well, let's say point B is our lowest height then. And then our height above that is going to be our height to point A, h. Now if we look at this triangle here, we can see that this angle of this triangle is the same angle, 20 degrees. And h is going to be equal to d times the sine of 20 degrees. So that is our height at point A. We're also told that the kinetic energy at A is 2 joules, and we have a frictional force. Now the frictional force is going to equal mu times the normal force. As this thing is going down this incline, the normal force is going to be equal to the component of gravity, mg cosine theta. So that would be our normal force. So this frictional force, which is mu times normal force, is going to be equal to mu times mg cosine theta. And that is going to be equal to 0.4 times 2 times 9.8 times the cosine of 20 degrees. That's equal to 7.37 newtons. So we have this frictional force of 7.37 newtons working against the motion that is going down the incline for the whole time. Alright, so let's try our one equation to rule them all. We have the kinetic energy at A plus potential energy at A plus any work done along the way equals the kinetic energy at B plus the potential energy at B. But we're going to define our potential energy at B to be 0. That's our lower height. And we just barely come to rest at point B, so we have no kinetic energy there. So what we have is that the kinetic energy at A, which is 1/2 mass, well actually we know the kinetic energy at A, which is 2 joules, plus the potential energy at A, which is mg height at A, plus the work done along the way, which is going to be negative frictional force times distance, is equal to 0. Or frictional force times distance cosine 180 degrees, which is a negative FD. So we have that 2 plus the mass times g times d sine 20 degrees minus f times d equals 0. Let's solve this for d. Factoring out the d and putting the 2 on the other side, we have d times mg sine 20 degrees minus frictional force equals a negative 2. So that is d times 2 times 9.8 sine 20 degrees minus 7.37 equals a negative 2. So d is equal to a negative 2 divided by all that other stuff, which is a negative 0.667, which is giving us 3.0 meters. So the distance d down the incline is 3.0 meters. That's how far it will slide before the mass comes to rest.